aldehydes, ketones, and amines, whatever we can. I have mostly come in as exercise here for this chapter, so that we'll discuss simultaneously. So I'll start sharing. So the chapter on aldehydes, ketones, carboxylic acids. So here again, the chapter deals with all the structure, the IUPAC naming, aliphatic aromatic aldehydes coming in, the preparation methods and the chemical reactions. Mainly we have oxidation of aldehydes, reduction, then we have nucleophilic addition reactions, then we have reactions due to alpha hydrogen, the aldol condensation reactions, then we have Cannizzaro reaction and electrophilic substitution reactions in aromatic aldehydes. So these are the basic things we deal with in the chapter related under aldehydes. Similarly, ketones also, the structure elucidation, IUPAC nomenclature, preparation methods, physical properties, then chemical reactions, again undergoing nucleophilic addition reactions, oxidation reaction of ketone, reduction of ketones, then same aldol condensation also shown by alpha hydrogens. Cannizzaro, we are not dealing for ketones, and electrophilic substitution reactions of aromatic ketones. And coming on to carboxylic acids also, structure, IUPAC naming, the preparation methods, and the chemical reactions involved for carboxylic acids. And the learning outcomes, again, similar, all organic chapters, basic learning outcomes coming in, all related to this. So since we don't have much time to expend on all these, so coming mainly, if we go into our textual part mainly, when we come to aldehydes, anything specific, teachers, Banu ma'am, anything specific? So nomenclature, as I was telling you, common names we have to, for those which are there in the text, we have to also tell the students to learn. The main thing is the structure of the carbonyl group, isn't it? This is what is very important here. So carbonyl group, due to the difference in electronegativity of the CO, we have the CO, C plus and the O minus. So carbonyl compounds show nucleophilic addition reactions. The reason for that is basically
formation of that C plus and O minus.
C plus, is it not? Because of the electronegativity and the pi electron shift onto the oxygen, we have the carbonyl carbon as an electrophilic center. So a nucleophile can easily attack the nucleophilic center. So that is one. So the rate determining step is where the nucleophile attacks the carbonyl carbon. So that is why that's why we call it as nucleophilic addition, and followed by the attack on oxygen. That's the first step. So we consider this as the rate determining step. So structure elucidation of carbonyl compounds, and why carboxylic acids do not behave like carbonyl compounds. So not, that's one thing. In carboxylic acids also we have the C double bond O. But it is not showing reaction similar to aldehydes or ketones. So here, what explanation do we give to the children? How do we explain it?
The two resonance structures.
Yes, Nasa, because of the lone pair on oxygen that is involved in the resonance. So the carbon there is not so. It cannot be considered as an electrophilic center there because of the lone pair sharing in. And therefore, we are having the resonance coming in. So CO minus double bond OH with one lone pair. So this is the reason why carboxylic acids do not show major reactions shown by carbonyl compounds, aldehydes or ketones. So that's one difference we have to tell the children, emphasize there. Why is it separate there? Then preparation here, oxidation, dehydrogenation and all we deal with in the previous chapter, but ozonolysis of alkenes, this we are teaching them in class 11. So we have to take up here once again, because many reactions where we take up this, and also this one. Hydration of alkynes also we have to reteach, refresh once again here when it comes in. And important name reactions coming in, Rosenmund and Stephen, and ketones getting reduced. So all these many name reactions coming in here. So ketone preparation specifically, apart from that, the two methods here, how we can convert, isn't it? Grignard reagent plus ketone, we are getting a second secondary alcohol, whereas Grignard reagent with a nitrile, we can convert it to a ketone. So those
Ketone.
specific, again, wherever we need a step up and all that, we have to use these reactions coming in. And physical properties. So once all the 4 chapters are done, we are comparing hydrocarbons, we are comparing haloalkanes, we are comparing aldehydes, alcohols for their solubility. We talk about the boiling point and all that. So very important questions of arrange in order is very sure to come in board exams. So all types based on boiling point, based on solubility, all this. Then acidic and basic behavior. So in carboxylic acid, acidic behavior. In amines, basic behavior arranging in order is very important. Haloalkanes, it's based on SN1, SN2. So those type of arrange in order is one of the main sure questions in organic part in board exams when it comes in. And the main reactions is not so many nucleophilic addition reactions. So why this part, a reasoning question that always comes in, why aldehydes react more to in nucleophilic addition reactions than ketones with both the points, steric reasons and electronic reasons. And this is one question, is it not? Benzaldehyde is more or less reactive. So because of the resonance coming in, again, the electron shift, electron releasing effect of the benzene ring, the positive charge here on the benzaldehyde carbon is reduced. So it is less of an electrophilic center. So reactivity is less compared to propanol, where we have CH3, CH2, CHO when this comes in. So this is plus I group, but here electron releasing is more. That's the reason coming in. So those parts, then all the different compounds which are formed here, and especially this is not all the derivatives, they should be knowing the nomenclature. They should be knowing what are the groups they have to substitute with so that they can write the final product. And especially this one, 2,4-dinitrophenylhydrazine is a test for distinguishing carbonyl compounds being distinguished from any other. So this can be used for distinguishing tests. Then all reduction reactions, again, here we have 2 name reactions with different reagents coming in. Oxidation, so oxidation of aldehydes is fine. Ketones, we getting a mixture of acids. So this is one thing. So Popov's rule, where you have the carboxylic acid, how it goes with which major product and all that. Tollens, Fellings, very important. So when it comes to Fellings, often the children make a mistake. Aldehydes, now we go for Tollens or Fellings. They forget the fact that Fellings reagent is not answered by aromatic aldehyde. So that's one point we have to stress on. And iodoform test, apart from ketones, what all gives iodoform test, we have to stress, no? Alcohols, all the secondary alcohols with a CH3CHOH can answer iodoform test, as well as ethanol. Ethanol and all secondary alcohols containing a CH3CHOH, and among aldehydes, ethanol. So these are the species which can answer iodoform test, and all methyl ketones. So this is the another specific thing. So wherever we can have a distinguishing test, ethanol with any other aldehydes, we can only go for iodoform test. And particularly whenever distinguishing test comes in, as we were discussing the other day, the board mark distribution is always for the name of the reagent and the observation. So very important. Even if they don't write the reaction or anything, no harm. So if you're asked to differentiate between, say, propanol, acetone, and say pentanol or propanol, anything. So what they have to go now, if it is iodoform, you're giving the name as iodoform test. So reagent here, we can tell them to write it as a tabular column, reagent. So it is NaOI or NaOH plus I2. So here we are going to get a yellow precipitate, whereas here no yellow precipitate. This is how we have to, it's easy way to teach the children to study it in this way. So if they know the reaction, well and good, let them write additionally.
Am I right, ma'am? Like a tabular column, they have to read.
Yes, ma'am. That will be the best thing. Write the name of the compound, reagent name here, and name of the test on top. So give them as a tabular column. It will be very clear. And if
Yes,
the
yes.
child knows the equation, additionally let him or her write. That's not very important because every
Okay.
time they insist. So it's like
Hmm.
half mark for reagent, half mark for observation. The child is writing all the equation but not writing yellow precipitate, he won't get mark.
Yes.
So very important that we tell them, we stress them,
Hmm.
any reactions, this is what, this is important, this is important.
Yes,
That's the thing. So whenever we give them practice, that is the thing. And the most another important part is not aldol reactions. Mechanism is not needed. It's only basically to show the nature of the acidic hydrogen. Beyond that, mechanism is not needed. So when we teach or when we give them the children, we can just tell them easily. One of them is the aldehydic part. And this is where they go wrong. Sometimes if it is propanol, is it not? They'll go to the end carbon. They'll abstract the hydrogen from the end carbon. So first we have to teach them it is always the alpha hydrogen which is being used. So alpha hydrogen. So tell them to first identify the alpha carbon. Alpha carbon, and from that they can extract. So mechanism is different, but we can just easily tell them to just shift off the hydrogen onto this.
Yes.
An easy way of remembering, techniques to remember, that's all, though it's not the actual mechanism. So CH3, CH, that OH comes here, and then tell them to connect that carbon here. So this will connect here. So we are having CH, and the branched part, let them write up or down. So that way aldol comes off. So the first thing, identifying the alpha carbon and shift that hydrogen onto that oxygen there. So that way it's easy for them to connect, though that's not the mechanism. And then when it comes to condensation, if it is condensation, they have to remove the
water
next alpha carbon hydrogen that is present. So that way getting the condensed product. So depending on whether it is aldol that is asked or the aldol condensation, if the question is to write the aldol product, then they have to stop here. If they are asking aldol condensation product, we have to go in by heating and eliminating. So depending on the question, they will go to write the product. Always, sometimes it may be to write the aldol. So then they should not go for condensation. But whenever it comes to ketone and all that, acetone always goes in for condensation product. That way, some things always give condensation product. When it comes to this, all this. So anyway, those basic things. And Canizaro, anyway, we are learning with respect to only aldehydes. No keto Canizaros we are not going in for. So if there is no alpha hydrogen, how they go in for Canizaro in presence of concentrated alkali. So basic information. And another thing is all this aldehydes, all these are meta-directing group, carboxylic acid, aldehydes. In electrophilic substitution, they go in for meta-direction. So class 11, we have already taught them, but we are just going into, once again, all this comes in application here. So they should be very thorough about which is the meta-directing and ortho-para-directing groups, like we discussed the other day. Ganesh sir is joining. Namaste, sir. So these type of questions, arranging.
Good evening, ma'am.
Good evening, sir. Namaste. So these type of questions, we have to give them a lot of practice coming in. And carboxylic acids also, basically, again, this is what we discussed, why it is not the resonance stabilization coming in. And again, all this we are teaching them in the alcohols chapter. And another important reaction, irrespective of the alkyl groups, if you have alkyl groups attached, that's alkyl benzenes, primary, then we are having secondary alkyl benzenes, all will be converted to just benzoic acid, irrespective of the number of alkyl groups, primary, secondary, tertiary. Suppose I have CH, CH3, CH3. This will also be converted to carboxylic group. Whereas if it's a tertiary, it will not. There's no hydrogen here into which the oxidation part comes in. So tertiary will not undergo oxidation. It's only primary alkyl benzene, secondary alkyl benzenes, which can be oxidized with alkaline KMNO4 followed by acidification to the carboxylic acids. So that one there. And also alkenes also, strong oxidation will be converted to carboxylic acids. Alkenes will be converted to carboxylic acids. HCOOH2. Yes, sir?
Madam, irrespective of whatever the length of the chain, that whole will be converted into carboxylic acid.
Yes, sir. Only to
Why,
COOH. Yes, sir.
Why,
Yes, sir.
madam?
So that is only this part gets oxidized, and this is what is forming the product. The carbon attached, the carbon with the hydrogen.
That only will be
This entity, yeah, gets oxidized.
remaining two carbons.
You will get other products. Yes, sir. We'll be getting other byproducts.
Okay, okay. It may
Yeah,
be ethanoic acid, maybe, huh?
Yeah.
Okay, madam. Thank you.
And now coming on to this part, another where we can go in for a step up, ascending the series. Any Grignard reagent with carbon dioxide followed by acidification, you can convert it to a carboxylic acid. So wherever we have a step up coming in, we can go in through Grignard. A haloalkane can be converted to a carboxylic acid through this method or using nitriles, either converting using KCN or converting with magnesium to Grignard reagent. So whenever step up related to last chapter, a lot of conversions coming in. So all those coming in. And esters reducing to carboxylic acid. So just a basic gist here. And all further reactions of carboxylic acid. So this one, acidic behavior now again. The presence of carboxylic acids, if we are having electron withdrawing groups, always. If we are having electron withdrawing groups, say suppose I have CF3 here. CF3COOH. Acidic behavior will be more or less?
More, ma'am.
Yes, more. So how do we explain, sir, to the children?
Easy to remove that H plus ion.
Yes, so it is due to the minus I effect. No? That's how we'll tell the children. Minus I effect of the fluoride group will pull the electrons away. So OH bond becoming more polar. So due to the minus I effect of the fluorine groups present, the OH bond becomes more polar. So polarity increases and thereby acidic behavior decreases. Whereas if we are having electron releasing groups, the OH bond is less polar. So acidic behavior is less. So this part and the resultant stability of the conjugate base. So we can explain on that basis. And again, in presence of electron releasing and electron withdrawing group on the aromatic ring, just like we discussed the other day, for alcohols, here, if you're having electron releasing group, again, the polarity of the OH bond will increase or decrease. Electron releasing group?
Decrease.
Yes, OH bond polarity decreases, so it is less acidic. So pKa value is high, so less acidic. Whereas electron withdrawing group will pull the electrons, making the OH bond more polar. So pKa value is less. So neither group, so benzoic acid just coming in middle. And all the basic reactions. And we usually don't emphasize much on this, though nowadays they say even these are for evaluation. This was this year's question, right? We had a phthalic and hydride phthalic question, though it is complicated. Yeah, direct question. Some of the children will usually learn this and write. Some may find a big reaction. Yes. Another one where we use in conversion, Helvolat-Zelinsky reaction coming in. So basic things. So I think with this, we'll go on to our discussion here. So we have something like this. How do we, if you could just finish off and then we'll discuss teachers. If you could just finish off, just give me the names of the reactants.
Number 6, haloform, ma'am.
Number 6, haloform is the product. Yeah. So what do we use there?
Sodium hydroxide and iodine.
Yes, sodium hydroxide and iodine, right. So NaOH and I2 will be a reagent here. Yes.
The first one, Tollens test, ma'am.
Yes, first one is Tollens. Yes, sir. Right.
Ammoniacal silver nitrate.
Ammoniacal silver nitrate. No, so we write it as AgNH3 twice plus OH minus. Yes.
Second one, Fehling test, ma'am.
Second is Fehling. Yes. So you just write it in equation as this, right?
Third one, addition reaction, ma'am.
Addition, yes. Addition of
HCN.
HCN. HCN, right. Fourth one is to alcohol. So,
Alcohol.
Reduction.
Finally,
yes.
alcohol.
So we can use
Nickel, ma'am.
nickel, hydrogen, is it not?
Yes, ma'am. Na bar H2.
Okay. Ni bar H2. Or we can go for lithium aluminum hydride, sodium borohydride. Any of that can go for reduction of aldehydes. So we have an aldehyde, we have a ketone. So aldehyde, we get this, and the ketone, we get this. And what about 7 is?
7.
Oxidation reaction.
Oxidation. So what can we use, sir?
Acidified potassium permanganate.
Yes.
Toluene.
So?
We can use toluenes and palings also.
Toluenes and phelings also. Yes, sir. Because aldehydes can be used for ketones, sir. This one?
Ketone strong oxidizing agent.
Yeah, so we can't use for ketones. So for aldehydes and ketones combined, we can use acidified KMNO4 dichromate. For aldehydes, we can take toluenes or phelings, but not for ketones. We can't use that for ketones, right? And fifth one is, what is our product?
2,4-DNP test, ma'am.
Yeah, it's a 2,4-DNP test. So we need 2,4-dinitrophenylhydrazine. And the product we get is 2,4-dinitrophenylhydrazone. So even this, if children get a knack of writing, is it not? NH, NH2. If they get to know how to write the product, they know the structure, now it becomes easy to start writing. If they get to know what it is. So they need a practice of writing the compounds and trying out. So this is one slide I thought we'll just go in for discussion. Okay, let us take this. Again, it's similar. Benzaldehyde and aromatic aldehyde taken, almost all are similar. So here, products are not given, reagents are given here.
Yes, ma'am.
KMNO4 H2 is for benzoic acid. Am I right, ma'am?
Which one, ma'am?
Right side.
KMNO4 H2SO4 will be benzoic acid, right?
Benzoic acid.
Right.
Next one also, ma'am.
Next one also the same, yes.
Yes.
Both are strong oxidizing agents, right?
Yes.
Reduction.
Reductions are yes. So we'll go to
Benzyl alcohol.
benzyl alcohol, right? Here we go in for,
Benzoic
Tolerance
acid.
reagent.
Sodium salt of benzoic acid.
yeah, we get, because, yeah, we usually use sodium hydroxodium alkaline, is it not? So we get it as sodium salt, right? Phelings will get it as, again, it's sodium potassium tartrate, Rochelle salt, is it not? And copper sulfate aqueous. So here again, CO minus, or we can write it as CO minus, CONA. And here now our product.
Ma'am,
Yes, sir.
aliphatic aromatic.
Yes, sir. I'm sorry. This one will not answer. Correct, sir. Sorry. Phelings reagent won't answer.
Oh, aromatic.
Thank you, sir. Yeah, that's what.
Yes, yes.
It's aromatic.
Mm.
So no reaction.
Yes.
Aromatic aldehyde, right? Yeah. And coming on to HCN.
Madam, baking test will not be given by benzoyl. Am I right, madam?
Yes, sir. Yes, sir.
Madam, what is the exact reason, madam?
Sir, Srinivas, sir, any specific reason, sir? You teach for NEET and all that?
Yes.
Yeah, I had been analyzing. I did not get an answer specifically as to why. I had been checking. They have not, a reason, proper reason was not.
I thought that benzoylate is less reactive. There is a mild oxidizing agent. By that I thought.
Will not be enough, right?
Yes, ma'am,
Because
ma'am.
we are having
Because
this.
already we compared to the aliphatic aromatic. Aliphatic is more reactive compared to aromatic aldehyde.
Yes.
So that is a very mild oxidizing agent. That's why I thought like that, ma'am.
Yes, I do think so. That's right, sir. Correct. Because mild and this coming in and attacking of this will be difficult. Maybe that's the reason. So you need a stronger, just like ketones coming in, this group, it can push electrons here, is it not? So like ketones, that should be the reason, as sir was saying. And coming on to this, the next one, HCN,
Addition reaction.
addition. So we are going to get
Cyanohydrin.
cyanohydrin, CHOHCN. And with 2,4-dinitro, as we saw there,
Yellow.
we are going to get CH double bond and NH with the benzene ring. So that will be our
If we
products.
give
Yeah.
worksheet like this means which will be useful for students. Am I right?
Yes, ma'am, that's what. So we have to
Mm.
give them practice like this, either missing reagents, either products, or a combination of both. So they'll begin to practice a lot. So we can
Yes.
try these type of questions for the children.
Yes,
Right.
yes.
And ketones also now anything different, otherwise we can just skip it. So when it comes to ketones, again, same reactions.
Yes,
2,4-dinitro, NaBH4, we are getting,
Alkane.
we get alcohol, no, sir? Yes. We get
Secondary
secondary
alcohol.
alcohol coming in here. The same we get for this one also.
Isopropyl.
Isopropyl alcohol, yes. Alkaline aqueous iodine reflex. So this is,
It is
yes,
hydrocarbon.
this is we get our iodoform, CHI3
Ethanoic acid.
and CH3CON, right? And this is again reduction. Tollens, Fellings, both will not, Tollens and Fellings,
No reaction.
no reaction, yes. And this one with HCN, what are we getting? With a trace of NaOH.
And here was ma'am, here KMNO4 is testable also there, ma'am.
KMNO4,
After tolerance failing, KMNO4 is testable.
so this will answer. This will not answer, this will not answer. This will give us,
Based on the breaking of the
yeah, we can have both breaking coming in, CH3, C double bond O, CH3. So we can have either going with this, going with this. So anyway, it is going to be two products, no, sir?
Yes, ma'am. Yes,
We get acetic acid and we get methanoic acid, right?
yes, ma'am. Methanoic acid again converted to carboxyl.
Carbon dioxide and water. This is not very, so it will immediately go for CO2 and H2, right? If we break, because it's similar, even if I break on this side, I'm going to get the same. It will be carbon dioxide, water and ethanoic acid. So because that way, otherwise depending on which one, right? So this will answer, these two will not answer. Coming on to this one with HCN, what are we getting?
Cyanohydrin.
Yeah, we get cyanohydrin. Yes.
Cyanohydrin again. Lithium aluminum hydride means
Lithium aluminium hydride is told, yes.
the
So-
cyanide became amine, ma'am.
Yes, CN, the cyanide alone gets reduced, no? This part will get reduced. So we are going to get CH3, CHOH, and we get CH2NH2. Right, this is what we'll be getting, right?
Again, this
So
is
this
H2SO4,
part. H2SO4 heating will be
dehydration reaction.
dehydration, right? Yes. So we'll be getting this dehydration, both are equivalent. So I think either side is fine, no? So this
Yes,
is
ma'am.
what, right now? Right, teachers?
Yes, ma'am.
This will be a product. Yes, dehydration. So OH and H eliminated. Both sides, it's methyl group. CN will not be touched, right?
Yes,
So
yes.
these are the things. So something like this will give a lot of practice to the children. Once they know the reactions, they can try to go on. So I just looked into, I thought if we just go in for this type.
Madam, top.
Yes, sir.
You didn't. That hydrogenation you didn't say, madam. Hydrocarbon only element product.
Where,
is the
where,
product?
sir, did I leave out something?
Yes, madam. Top.
This one.
H.
It will be
yes, ma'am.
reducing to alcohol only, no?
Secondary
Alcohol
alcohol.
only, madam.
Yes,
Yeah.
ma'am.
Secondary alcohol.
This also secondary alcohol. Ketone will go to alcohol. Further reduction, no. Yes, sir?
Yes. Got
Right?
it.
Yeah. And this one is similar. That's why I thought, no, we have
Yes,
done
yes,
2,4-dinitro.
Yes.
Yes, that's what. When it comes to this one now.
3-methyl
Second.
lithium aluminum.
Secondary alcohol, ma'am.
Which part, ma'am?
Only.
This one, huh? With
First
the
one.
lithium aluminium hydride.
Lithium aluminum.
Yeah. So our ketone part will get reduced, right? Yeah.
Yes, ma'am.
CH3.
CH.
So we are getting the secondary alcohol here, right?
CHOH.
H2SO4 dehydration reaction.
H2SO4 dehydration. Yes. So dehydration,
But
they've
here,
already given us one product, right?
Yes, ma'am.
They've given us one product, so the possibility of eliminating, is it not? We
Is
can
from
have
the second carbon. Second carbon.
major product will be this one, right?
There's the
Yes,
problem.
ma'am. Yes.
And the other possibility is this one. So this is what they have shown us, this one.
Yes,
This one.
ma'am.
Major.
Yes, ma'am.
And the other
Okay.
possibility is CH3 twice, CH double bond
Double bond,
CH2, right?
Yes, ma'am.
So here, what will be our starting material here? Have I written right?
Yes, only, ma'am.
Yes, ma'am.
Right. So it's what gives us this one? 3-methyl butanone, H2OH. So this is from dash to ketone. This should be and hydrogenation of something is giving us this. So this should be
Hydrocarbon, madam. Hydrocarbon.
alkyne, right, sir?
Yes, ma'am.
Alkyne.
Yes, ma'am.
No, hydrogenation means alkane, madam.
Alkyne, no, sir. We are
Alkyne.
adding.
Yes.
Adding no, ma'am.
Alkane.
This should be right, no?
Yes, ma'am.
Ma'am, alkane.
Yes.
Alkyne hydrogenation converting to alkene.
Okay, okay,
Yes,
right
ma'am,
side.
yes, ma'am.
And it's alkyne
Again, ketone.
hydration in presence of mercuric sulfate and sulfuric acid,
Yes,
which gives
ketone.
us ketone.
Right. Yes,
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 ma'am.
yes.
Yes, the tautomerized product.
Yes,
Yes,
ma'am.
ma'am.
We'll have OH getting attached here, H getting attached here, then there's the shift here. So tautomerism happening. So this is all these, no? And when we do it this way, I think children will find it interesting also, is it not?
Yes, yes, ma'am.
Applying rather than just
If
giving.
it is that word like problem, they can write if you give like this.
Yes, that's what. So different ways where we can nurture interest in doing,
Yes, ma'am.
children trying to
Yes, ma'am.
solve. So this
Yes, ma'am.
type of things will help them out. So that's solution there. So are all reactions of carboxylic acid from ester, we can convert to acid, from anhydride to acid hydrolysis, most reactive. Acid halides to acid, these are very reactive. Then amide, all hydrolysis, no, that's very simple where we teach the children all this. What about this? Carboxylic acids, a few. It's the missing reagents here now.
Acid base reactions, ma'am. That first one.
Acid base, first one, yes, sir. So which, here we have 2 in 1, they have given carbon dioxide. So this can also be, this can be sodium, this can be sodium hydroxide, right?
Yes, ma'am. Sodium hydroxide.
Sodium, no, only one product. Sodium hydroxide, we'll get also water as byproduct. Here they've given with carbon dioxide as byproduct. So we have to specifically,
Bicarbonate. Ma'am.
yeah, bicarbonate or carbonate, right?
Yes, ma'am.
Any of this we can use. So because they have given that additional product, we can go in for that. Acid chloride,
SOCl2.
SOCl2, yeah.
Yes.
SOCl2, they've given HCl as the product, right? So SOCl2 now we'll also get SO2 along with that, right?
Yes, ma'am. Yes, ma'am.
RCOCl, PCl3 or PCl5, any of those also. Depending on that, products will change, byproducts.
Yes, ma'am.
Ester,
Alcohols, ma'am.
yeah. Since they've specified R dash, so we'll go for R dash OH.
Okay.
Ammonium salt.
Amide.
Ammonium salt will be just
Ammonium, ma'am.
ammonia.
Yeah.
If we heat, it goes to, if this is heating,
Amide.
we'll give amide.
RCONH2.
Yeah, that's what, amide. And this is now
Alcohol
reduction, right?
That's right.
So we
Yes,
can
ma'am.
go for any reducing agent, acid to that, yes, that way. So those coming in.
Diborane also given.
Diborane also, yes, sir, that's what. Diborane. Only NaBH4 cannot be used. The other day while we were discussing lithium, aluminium, diborane, sodium, ethanol, all of these can be used for reduction, right? Acid conversions. Acid. If we can spend some time, we'll just sum up all the reactions.
In sodium carbonate, sodium hydroxide, sodium metal. These three same product, ma'am.
These three same.
Yes,
All
yes,
the
sure.
three.
Sort of carboxylic
We are going to
acid.
get sodium
CO.
Na. Lithium aluminum hydride we are getting.
Reduction. CH3 CH2 vachama.
Yes, we get ethanol.
Hmm.
Then what do we have? CH3COCl, converting acid to
Acyl halide.
acyl halide. So what do we use here?
Acetyl chloride.
SOCl2.
Acetyl chloride is the product. So we can
Yes,
use
yes.
SOCl2 or PCl3, any of those, no?
Yes,
We
ma'am.
can use this. They've shown the reverse.
Reverse.
Acid chloride.
Acid chloride to acid.
Hydrolysis.
Hydrolysis. Ester, acid to ester here. It's methyl ethanoate.
With alcohol.
Yeah, which alcohol do we choose?
Methanol.
Methanol, right? Yes. So to form in presence of acid, right?
Yes, ma'am.
Acidic medium,
Mm. Yes.
right? And reverse also, reverse will be hydrolysis, H plus
Yes.
or OH minus. Reverse
Yes.
reaction will be H plus or OH minus. Acidic or basic hydrolysis, right?
Yes, ma'am.
Right.
Acid
And
chloride.
coming-
This is also sodium acetate, ma'am. NaOH heating sodium acetate.
Which one, ma'am?
What we
Ester to
that
this.
ester on yes,
Ah.
NaOH heat.
We get sodium acetate, right?
Yes, ma'am.
Yes.
Sodium.
CH3CONA will be the major. Yes.
Yes.
Acidic hydrolysis. So NaOH, no? So that way we'll go in for this only, yeah, right?
Sodium.
And acidic, this is acidic hydrolysis. So we'll get CH3COOH and CH3OH. Acid and alcohol. Here we get salt of the acid and alcohol, right?
Yes, yes,
Yes,
ma'am.
ma'am.
That way, right? Yes. Acid, chloride, and amine.
Where, ma'am?
This one.
Acid chloride. Acylation process, ma'am.
Yes,
Amine.
acylation, right? Yes.
Yes,
So we get it as,
K3NH, CO, CH3.
yes, NHCH3. It's the HCl that is getting eliminated. So we are getting CH3CONH, CH3. So we are getting the amine. Acetam, is it not? CH3CONHCH3, right? So that way, all these major products, I think these are the main ones which we teach the children, right? Coming on to
Yes, ma'am.
acid and amine. Acid and amine reactions, again, goes in for the same, right? Acid and amine also can be the same, right, sir?
Yes, ma'am. Yes,
CH3CO, NHCH3. So all these are same products. Ganesh, sir, is it fine, sir?
Yes, madam. Okay.
Right, sir, right. An acid medium,
Yes, madam. Sulfuric acid.
Acid will get, ma'am.
acid, no?
Yes,
Yes,
ma'am.
madam.
And NH2,
Sodium.
right?
Mm.
Okay.
And if it's basic medium, we should be going in for the
Sodium
salt, I
salt.
suppose.
Sodium salt will get.
Right,
Salt.
that way. This should be the case. And here, reduction of ester, again, acid, we get the corresponding alcohols, right?
Yes.
COOH will reduce to CH2OH and we'll also get CH3OH, right?
Alcohol.
Ester reduction with lithium aluminum hydride, strong reducing agent. Usually dibal H is used, right?
Yes.
Dibal H is more sufficient.
Yes, ma'am. Yes, ma'am.
Case comes in, dibal H.
Right.
Nitriles, esters, is it not?
The aldehyde preparation. ma'am.
Aldehydes, yeah, that will stop at aldehydes, sorry, yeah. Esters to alcohol will be lithium aluminum hydride.
Okay, ma'am.
Dibal H stops at aldehydes,
Aldehyde.
yeah. So I think this part, already products are here, so I think I'll skip this one. We can give these type of worksheets to children, is it not? What is the function in the beginning? When we are starting to teach all this, we can give the compounds, we can give what identify the organic functional group, then write the IUPAC name and so on type of questions. Teachers, if we can just do this in 5 minutes.
Potassium salt of benzoic acid. Potassium benzoate, madam. And further I will give benzyl alcohol.
Benzyl?
Alcohol.
Yes, sir, right. So first product is right, teachers. So alkaline KMNO4 followed by acidification. This part will convert to benzoic acid and lithium aluminium hydride results in benzyl alcohol. Yes.
Second, first is not
First one, this one, huh? Okay. Grignard reagent. Am I, is sir audible? Sir, for me, you're not very audible.
Some disturbance, sir.
Is it? Yeah.
Yes, yes.
So first step, as sir told, yes, Grignard reagent. Second is with the formaldehyde.
And second one is
Now
benzyl
clear.
alcohol, madam. Benzyl alcohol, madam.
We get benzyl alcohol, right? CH2OH, right? And hydrolysis, no? This put together. Second and third step put together, we're getting benzyl alcohol. And then when we treat it with this particular acid chloride followed by pyridine.
That one.
That's
Acid chloride.
acid chloride and alcohol in pyridine medium.
Okay. That is that is you tell me.
Yeah, somebody else can tell, right? We all are just interacting, that's all. Yes, ma'am, Srinivas, sir. So it's the elimination of H and Cl.
Ketone.
It's a keton.
Sir,
It's a keton, no?
Ketone. Yes, ma'am.
Not a
ketone.
keton,
Ester, ma'am.
ester. No?
Okay, okay.
Get an ester. Alcohol and acid chloride, alcohol and
Okay.
anhydride, alcohol and acid will result in ester. So we have a CO, CH2, CH3 here. So we are going to get O, CO, and this. So this part is attaching through the carbonyl carbon of this one. From here, it attaches. So we're getting the ester there, right?
Hmm.
So it's first step Grignard reagent, then with formaldehyde to form the primary alcohol, and then ester formation. Yes. Now coming on to the top one, if we go for this one,
Nucleophilic substitution reaction.
yes, nucleophilic addition reaction, right, sir?
Substitution reaction.
Sorry, substitution, right. I'm still with aldehyde chapter, right? CN, right.
CN will get attached.
So here with the phenyl magnesium bromide with the acidification, we'll be getting it as, I think this one, right? Phenyl and OH. Am I right?
Hmm.
Sorry, C double bond O.
Yes.
C double bond N, madam.
C double bond O, MgBr comes in. So this one, reaction will be C double bond N MgBr
Yes, madam.
with pH.
Further
Then
another
acidification will become O, double bond O, right?
Yes, ma'am. C double
Double bond O. C double bond O, C6H5. This is what we'll get.
Yes, ma'am.
C6H5. This is what we'll get. The next one here, similar.
RMGX.
You're getting RMGX,
Grignard
Increasing
reagent.
carbonate.
MgCl with carbon dioxide and this together.
Benzoic acid.
Yes, this converts to benzoic acid. Benzoic acid with thionyl chloride.
Benzoyl chloride.
We get benzoyl chloride. And then back to our pyridine and this one, alcohol.
HCl.
Ester, madam. One kind of ester.
Yeah, we
Ester
get an
pyridine.
ester here now. The ester here will be O. Am I right?
Yes.
Have I written right?
Yes, madam.
No, this
Yes,
H,
ma'am.
this Cl and this H is eliminating. So O with this joining here.
Yes, ma'am.
This is our product. Yes, Bhanumati ma'am.
Actually, I have to move to home, ma'am, from school.
Okay,
School
okay.
closed. I'm still there in school.
Ha.
Ma'am, after 15 minutes, if possible, I will rejoin, ma'am.
Yeah, okay.
Sorry, ma'am.
Right. You'll be able to keep it on?
I will try, ma'am, because I have to drive.
Okay. Right.
That's right. Because all have gone except myself.
Okay,
Some
right.
aunties are there. That's why, ma'am.
Okay.
Sorry, ma'am.
Right,
Okay.
no issues.
Possible, I will rejoin. Okay.
Yes.
Yes, ma'am. Thank you.
Right. So this one, sir, coming on to this.
First one is preparation of alkyl halide, madam.
Uh,
About alkyl halide.
Alkyl halide, acid halide.
Acid halides.
No, this one. This is right?
Yes, sir. Top
Right.
acid halides.
Yeah.
And further treated with amine, primary amine, I will get amide.
Yes.
Am I
So we are going to get this, right? Double bond O. And this will become N, right? H2O gets eliminated. This and this will get eliminated. So we'll have NH coming in, right?
Yes.
I have it on this carbon, this way,
NHCO.
right? This H and this OH eliminates and we have a connection there. Yes? This will be the product.
Yes.
So it is formation of acid chloride followed by amide, right?
Yes, ma'am. Second
Ah,
step, ma'am.
Second step, right?
Yes, madam.
Acid chloride. Second step, amide formation,
Yes, ma'am.
right? And when it comes to nitrile with dival H,
We get aldehyde, madam.
Aldehyde,
yes,
ma'am.
this is, followed by hydrolysis, aldehyde. And here we have a nitrile with the Grignard reagent. So we get it as,
We get
Ketone, ma'am.
ketone, no? So this will be our ethyl from the Grignard and this becomes, right? Yes?
Yes, ma'am.
Right.
ketone is the product.
Ketone is the product, yes, sir. With
That,
ethyl coming in as additional part there, right?
Yes, madam.
And here we have the missing reagent here.
Yes, madam. Here,
Acid chloride, yes.
We are,
reducing agent, ma'am. First.
yes, sir. So we have a carboxylic acid to alcohol. So we can go for any, right?
Yes,
Fulkishner
ma'am. Lithium
or
aluminum nitrate.
Clemmensen reduction, madam.
Diboron.
Not Clemmensen, no, sir. This is acid.
Yeah.
Acid, we,
Yes,
yeah.
carboxylic acid.
So we can go for other reducing
Yes.
agents.
Lithium aluminum.
Yes.
Reducing it.
Second one, Clemmensen rule Pishner reduction.
This is Clemmensen's, right? Any of that, na? Zinc amalgam, HCl, or we can go for hydrazine followed by KOH ethylene glycol. Right, correct,
yes.
sir. And this is now our acid chloride to aldehyde.
Rosenman reduction.
Rosenmund, right?
Vanadium and barium sulfate, madam.
Right, sir. That's what. So we'll go in for such
Full
things.
Rosenmund reduction.
Correct, sir. Correct. Right. So these are the things. So I think aldehydes, ketones basically coming into all these. So what about these two? We have to teach children. These are the different types of questions that can be, no? We have to
Yes,
train the
one
children
question.
for when it comes to. So a lot of
2,4
such
DNP.
questions, we have to give the children a lot of practice from these types.
The 2,4-DNP means that is the carbonyl compound, ma'am.
Yes, this shows, this gives us a hint that it's a carbonyl compound, right? Negative
Negative
tolerance.
That means ketone, ma'am.
Yeah, not an aldehyde, right? Positive.
Methyl ketone.
So it's a methyl ketone, right, sir? So two structures have been asked. There are two possibilities coming in for the ketone.
This states an alkene A and original solution of the two compounds. Positive limitation.
So what will be the two compounds are here?
One is the aldehyde, ma'am. That the aldehyde means the second carbon contains CO.
Both are ketones, no, sir? Cannot be an aldehyde, no?
Yes, ma'am.
So first one will be,
But ozenolysis means.
no, this is another question, okay, sir? This is another.
Okay.
Yeah, sorry.
suggest to
So A can be any of the two.
2-methyl ketone, ma'am.
Yeah, 2-methyl ketone. So one can be,
CH3CO.
yeah,
Next CH2, CH2, CH3.
yeah, the normal pentane 2-on, right?
Yes, ma'am.
And the other one will be
ISO, ma'am.
iso. Yes, sir. Right. It can be isopropyl. Right. So these are the two possibilities that we can have with these, no? Yeah, right. And coming on to this one. So A alkene giving B and C. So B is giving positive fillings and forms iodoform. So it's an aldehyde and also answering iodoform test.
Methyl aldehyde.
Yeah, so that will be, and compound C is not giving Felling's test but forms iodoform.
That is a methyl ketone, ma'am. CH3CO,
Yes.
CH3.
Yeah. If we go in, is it a propanol? Is it CH3CO, CH3?
Yes,
What
ma'am.
will this be?
Propanol.
First one, B will be
Acetaldehyde, ma'am. CH3CH4.
acetaldehyde because that's the only one which will answer iodoform test, right?
Yes,
They've
ma'am.
told positive, so it's an aldehyde, and answering this, it can only be this. So the other one is giving Fellings, not giving Fellings, but forms iodoform, and we have 5 carbons in an alkene. So already 2 comes in here. So the possibility is only propanol, right? So our alkene will be,
Pent2-ene.
yes, pent2-ene, right. Right. This will be right, no, sir?
Yes, ma'am.
Right. Will it be propanol? CH3, CHO. This cannot be pent2-ene, will it be? No. This will give us an ozonolysis, will
Yes,
give
ma'am.
us,
Yes, ma'am. Aldehyde will get that means.
this should be,
Um,
this cannot be pent2-ene.
yes, ma'am. 3-methyl. 2-methyl. 2-methyl butene.
2-methyl butene, right. This will be right, no? Only then we'll get it as ketone. Otherwise it would have been propanol.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
So this should be the case, right? CH3, CH. I think a lot of such questions will train the children a lot. They'll be able to think what all reactions they have learned coming in with that and so on. One last slide from this part, sir.
Okay, ma'am. First, SOCLT means acid chloride, ma'am.
Yes.
Next one.
Benzene and anhydrous aluminum chloride.
Benzene.
But the benzene,
Acylation process,
Friedel-Crafts,
ma'am.
Madam, Friedel-Crafts acylation.
Yes, so we
Acylation.
get
Acetophenone.
C6H5,
Acetophenone.
COCH3, acetophenone is formed, right? With HCN,
And
Cyanohydrin.
cyanohydrin,
cyanohydrin, right?
hydrolysis.
Cyanide group carboxylic acid hydrolysis.
Yeah, and then finally we are having hydrolysis. So our D will be this, right? Right. So when we train them, we can also ask them to learn all the IUPAC names of these compounds and all that, right? So that way they get a practice in IUPAC nomenclature also coming in. And this one now, a ketone with Grignard reagent. So we are supposed to get a
Ketones.
ketone with Grignard reagent will be giving
That 1, 2, 3. That 3-membered chain will be attached to
Secondary,
that
yes.
carbon, madam, and it will
Right.
become a secondary alcohol.
We get a secondary alcohol, right?
Yes, ma'am.
Secondary, tertiary
Tertiary
alcohol,
Yes,
right?
yes, yes.
Tertiary alcohol. Keton and Grignard reagent hydrolysis tertiary. Right. 1, y dash 1, 2, 3. This will be extra. Right. And here we have a Grignard reagent with
primary
alcohol. We get a
primary alcohols, ma'am.
secondary here, no, sir? It's not formaldehyde.
Yes, ma'am. Yes, ma'am.
We'll be getting a secondary alcohol. So we're getting OH and the Grignard entity 1 connected. So this way it comes in.
Yes, ma'am.
1, 2, 3, 4. So 1, 2, 3, 4, right?
Yes, sir.
So we're getting a secondary alcohol here. Here we're getting a tertiary alcohol. So these type, I think maximum, a lot of questions where we use conversions of Grignard reagents and all coming in. Is it not many of the things coming in? I've got a big one here, sir. Before that, when we go in, if we'll come back to this, sir, when we go in for other chapter of amines, and here but particularly exercises when we deal with, I think very important that we train the children in these type of questions, is it not? So if they know that table properly, ammonia derivatives table, and then immediately practice questions of this type. We have to give a lot, 1 mark questions. This time also we have in our board exam, a lot of questions similar to this, no? So a lot of practice from this type of questions coming in. Then identifying which undergoes aldol, which undergoes Cannizzaro. So all these if they do the exercise of this chapter itself, it gives a lot. And we have this word problems type of questions. Then arranging, this is another important type. All of you would have sent children for the board exam, so we know very clearly. And this is what I was stressing upon, the chemical tests, very important that it's to be tests with observation. So all this coming in. And where we have to stick on to any specific type, no, not more than 2 steps, not using all this. So these type of practices come in this chapter. And completing reactions. Board exam always they ask for, you have to write sort of balanced equations. So whenever the question is like completing each synthesis, in boards they say that you have to write the byproducts also. If the child is not writing the byproduct, they are losing the complete mark. So for such questions, we have to train the child to write the byproducts, and wherever balancing possible, that also. Right, teachers? So that one thing we have to go in. So all these type of questions gives a lot of exposure to students. And another type of question is reasoning questions. So a lot of the types of questions that come in organic chemistry, distinguishing, reasoning, completing, conversion, name reactions, illustration, all the types of questions. This is another reasoning, very often asked type of questions. So we have to train them properly with all this coming in. And amines chapter. So when it comes to gas phase and when it comes to aqueous solution, is it not? 2 different cases. So when it's in gaseous phase, how is the reactive basic character? What is the only criteria which determines basic character in gaseous phase?
Inductive effect, ma'am.
It's only the inductive effect, yes. So here,
3 degree,
it will be
2 degree.
3 degree will be more basic, right?
Yes, ma'am. 3 degree, 2
Than
degree, 1 degree.
secondary than primary because of the plus I effect, more electron density over nitrogen, right? But when it comes to aqueous solutions,
Based on the 3 factors, ma'am.
yes, we have the,
Solvation effect,
yes,
steric effect,
inductive and steric effect, right?
steric effect.
Yes,
Okay.
all the 3 put together. So when it comes to steric, if there's more steric effect, it will affect the. So how do you explain? How do you put it across to children, sir?
So based on the pK values only, ma'am.
Yeah, pK. No, without giving the
Estimated
pK, without introducing pK, when we talk in terms of structures and all, how will you introduce? How will you explain? Like when we talk about, does it not? So if it's a tertiary amine, so extent of the number of hydrogens is less, and
Hydrogen
also
bonding also.
steric effect, is it not? The steric effect will, due to the hindrance, effect hydrogen bonding reduces, also the solvation number of hydrogens is less, so solvation effect is less. But what dominates is the inductive effect. So tertiary inductive effect is high, but steric hindrance more and solvation is less. So when it comes to secondary, again, compared to tertiary, steric hindrance will be lesser and solvation is slightly more because more extent of hydrogen bonding. And when it comes to primary, we have 3 hydrogens in aqueous solution, RNH, the conjugate species that is formed. So it will be 3 hydrogens coming in, RNH3 plus, RNH2 plus H plus, giving RNH3 plus. So the extent of hydrogen bonding is more here and steric effect is less, so solvation is more. So that gives primary species the higher priority. Inductive effect is less and steric effect is less, solvation effect is more. So we're putting into explaining all this to the children, talking about steric hindrance, talking about the plus I effect and the resultant hydrogen bonding of the resultant conjugate species that is formed. So based on this, when we talk about the preference or the order of basic character for methyl substituted amines, when it comes to methyl substituted amines, what will be the order?
Secondary is greater than, tertiary is greater than,
Yes,
primary is greater than,
always secondary is having the preference, right? Because we have the subtle interplay of both. So balancing both inductive effect and balancing the steric hindrance and solvation effect, always secondary amine, irrespective of whether it is methyl substituted or ethyl or higher amines, secondary amine will be the most basic. And when it comes to the small methyl group, beyond that, which factor dominates? Is it solvation or inductive? So secondary amine most basic, then comes in
tertiary and primary.
for methanamine, methyl. This is the order, right? For methylamine, it is steric hindrance is less, inductive effect is less, hydrogen bonding is more. Is it not? Because small methyl group. So solvation effect dominates over inductive. So it is always 2, 1, 3, right? Yes, teachers?
Yes, ma'am. Yes, ma'am.
Whereas when it comes to ethyl or higher, ethyl substituted or any other higher alkyl amines, again, balancing both steric solvation effect and inductive effect, it's again secondary, which is higher. But when it comes to primary, tertiary, in the case of higher alkyl substituted amines, inductive effect dominates over hydrogen bonding. Yes or no?
Yes, ma'am. Yes, ma'am.
Yeah, so it'll be tertiary 3 followed by 1. So ethyl and higher amines, always 2, 3, 1. Whereas methyl amines, it'll be 2, 1, 3. So balancing both the factors always secondary for whatever. So that is easy. A child, you can always tell them secondary irrespective of this. And tell them to learn, say, for methyl as 2, 1, 3. For all others, it'll be 2, 3, 1. So if one they are sure of, then this they just need to interchange this for the other amines. So this part is where, again, whenever order comes in, the child should be knowing where it may. So this is always 2, 1, 3. Whereas for this, it is 2, 3, 1. This or higher. So that's what is it. So it's a subtle interplay of all the ones. So in which case, what is dominating? That we have to tell the children. So based on that, after explaining only, we can talk in terms of pKb values. And aryl amines always. So here, when it comes to aryl amines, are they more basic or less basic than aliphatic?
Less.
Less basic because of this, yes. So that is another thing, we have comparison of aliphatic and aryl. So that particular exercise question and this instability of the resultant anilinium ion. So we can talk in terms of that also. So a lot of such questions, is it not? So we have here aryl and aliphatic comparison coming in. So based on all this, there are a lot of questions. So this we'll have to discuss with the children in detail, this part going in. And these two for the distinguishing tests here. So what are the distinguishing tests that we can give always? So primary amines, we can go for carbylamine and what else can we go for, teachers?
And diazotization.
Diazotization, aniline, sir.
Aniline.
Carbylamine, we can go for
aliphatic.
primary with any other. Then what else? Lieberman's is not given for NCRT, so we need not go for that. The primary amines, we can go for carbylamine, foul smell. So again, the reagent is important. CBSE board exam point of view, we have to teach the children to write the reagent and the observation. Even the product is not needed. Completion of reaction question now, we have to write all the products, we have to write the balancing also. So that whatever, what is the nature of the question? Carbylamine, can we go for Hinsberg for distinguishing primary with other amines? Yes?
Hinsberg test.
Hinsberg, we can go no, sir. Yes. And if it's aliphatic primary alcohol, can we go for this test as distinguishing? Evolution of bubbles of nitrogen, is it not? So aliphatic amine, we can also try this. Aromatic, we cannot go because aromatic amines, the diazonium halide is stable. So we cannot go for that. So for primary aliphatic alcohol, amines, we can go for carbylamine, we can go for Hinsberg, we can go for nitrous acid test. For aniline, you can go for carbylamine test. You can go for iodoform. I'm sorry. You can go for Hinsberg. Any other teachers for aniline? Aniline, what else? What test can we go for?
Madam, aniline cannot give carbylamine test, madam.
Aniline will give, sir.
Yeah, madam.
Yes. Both aliphatic and aromatic will answer.
Primary means.
Yeah, any primary will give. This nitrous acid test, we can't go because it is stable. The benzene diazonium halide will be stable. So it will not immediately convert to alcohol with nitrogen evolution. So this we'll use only for aliphatic because this will give stable benzene diazonium halide. Only when we warm, we'll get alcohol, phenol. So otherwise we won't. We can use this. And there are other tests also. No? For aniline, we can be more, there are more tests. Which others? Which other tests? What about bromine water tests, sir? With aqueous bromine? Yes or no? Can we go for this?
Yes, ma'am. Yes,
No, this can also be as a distinguishing test, aniline. But we can't distinguish with phenol. Phenol also 2,4,6-tribromo is a white precipitate. Aniline with any other amines, we can go for this. It gives a clear white precipitate, tribromo aniline. Then we can go for azodized test, benzene diazonium chloride with aniline. We have under this one, no? So that also can be used as a test. This one, giving a yellow dye. Phenol, benzene, azodide test. So phenol or aniline, we can use azodide test as a test for distinguishing. And so many reactions of benzene diazonium halide. So till last 2 years, this was deleted, but this year we'll have it. So a lot of conversions. So I think once we finish all the 4 chapters and we come back to this, so here again, reasoning, this is the important aspect where we have all the types based on PKB, based on basic strength, aromatic, aliphatic, then gaseous phase. So only when it is gas phase specifically mentioned, we go for tertiary, secondary, primary. If nothing is mentioned, we have to tell the children always do it for aqueous solution. If not, when they write the answer, they have to write whether they've written for aqueous solution or for gas phase. They have to be very specific. So if not mentioned, always the child, better that the child writes for the order in aqueous solution. Then order of boiling point, solubility, all this. So lot of practice we have to give in. And this amines chapter, if we do all the conversions, I think everything comes in. Is it not, teachers? From chapter 1 to 4 of this organic, if conversions of amines are practiced, everything comes in. Lot of step up, step down, everything, where we are acid to amine, all this, right? How do the children find it, sir, when they do? And another important type is this one, like ABC completions. So these type of questions, so we have to give a lot of practice to the children based on this. Now, amines again, all these we have same thing, amines, properties, learning outcomes are here. Classification of primary, secondary amines, how we have to go in. And as I discussed, the basic behavior. And based on PKB values comparison. So given the PKB data, they should be able to, from the data, how you will analyze. So here, which is the most basic? Most basic.
Secondary ethyl, madam.
Secondary ethyl. We have 3.25, is it not? So 3 should be more basic, no, sir?
Yes, madam.
N-ethyl ethanamine, as you said, secondary amine. Then we have this tertiary, and then we have methyl methanamine comparison. So based on our PKB values, and 9.38 is the highest. So benzenamine, aniline, having the least basic nature. So from the data, the child should be able to interpret. So aniline to various compounds. So aniline, we can see if we convert any of the aromatic compounds to aniline, we can convert it to so many other compounds. Diazotization followed by other reagents. So benzene diazonium as an important intermediate. We have to know the child should understand the importance of the formation of the benzene diazonium halide. Sir, this teaches this completion.
One is that left hand side, madam.
First one will be which compound? We start from?
Bromine will be replaced with cyanide, madam.
Oh, you're talking about this one, sir?
Yes, madam.
Okay, right.
Then further, when it is undergo reduction,
Yeah.
It will form imines.
Amine. Amine, no, sir? CH2, NH2.
Yes.
It will reduce to amine only. Yes. So that's
yes.
it. This with hydrolysis amines.
Yes.
Right.
Next, here this will be giving aldehydes. That beside one is aldehyde and ammonium.
No, sir. It's amide, no, sir. CONH2. So we'll get again?
Same number of carbon.
No, same, no, sir. Yes. So we get this, right?
What?
Yes, madam.
This will become this will become CH2. That's all.
Yes.
We are getting NH2. This is it.
Okay.
What about our first one here? Which one will be our first one, starting material? We have phenyl isocyanide, we have benzene, we have aniline, we have nitrobenzene.
Carbylamine reaction.
Carbylamine.
Yes, madam.
Which one will give carbylamine? So from where to where do we go when such a thing is given? We start with?
Alloyerins.
So we are using only these, sir. From these, we have to put a sequence. No addition of anything else. Only reagents we'll add on. So I don't think we need a haloarine as a reagent here.
Benzene, ma'am.
First benzene, right, sir? Yes. So benzene.
Nitration, ma'am.
Nitration, right. Corn nitric acid and corn sulfuric acid we are getting. The second thing is our nitrobenzene, right?
Yes, ma'am.
So this is benzene. Benzene we are converting to nitrobenzene, right?
HNO3, ma'am.
From here, nitrobenzene, yes, aniline. So what do we use for converting it to aniline?
Any reducing agent, madam.
Any reducing agent, we can go for tin HCl, iron HCl, and so on, right?
Yes, ma'am. Yes,
So there also lithium aluminum hydride, we have to be suitable, seeing whether it's aliphatic, aromatic, and all that. Yes. So aniline, then we go for
Diazotization.
no. Here we don't need diazotization.
Alkylation.
Uh,
Alkylation, ma'am.
Now we have only these two left. We have only
Amine.
isocyanide and secondary amine.
Ammonalysis, ma'am.
Necessary, sir?
No, carbylamine reaction, madam.
Yes, here we go for carbylamine, right?
Isocyanide.
Carbylamine reaction, CH3 and alcoholic KOH. So we are converting it to isocyanide, right?
Yes.
So this will be our fourth one. And then from there, obviously
From
this should be the fifth one. So
From
that is
aniline,
fine.
ma'am. From aniline only, ma'am.
From isocyanide we can, right?
Okay, ma'am. Okay,
Reduction?
Yes, ma'am.
Reduction will give, no, sir?
Yes.
Isocyanide will reduce to secondary amine, right?
Yes.
Cyanide, nitrile will give primary amine, isocyanide will give secondary amine. Am I right? Will this be correct? Sequence is right, no? Now this one here, the big one that we had in that chapter, we don't have time to cover that. Around 21 sets were there. At least this will finish off. Simple that we teach the children, now we give them so many types. So we have our chloromethane converting to cyano, ethane nitrile. So what will be our A?
KCN, ma'am.
Yes, we can use KCN. Yes, so nitrile, then it is hydrolysis. So B is our,
Carboxylic acid, ma'am.
yes, acetic acid, right?
Acetic acid, ma'am.
Acetic acid now. So here it is shown arrow towards acetic acid. So ethanol to acetic acid. So what should be our F?
We can
Yeah,
take toluene or tailing reagent.
Yeah, toluenes, Fellings, any of that, or a strong acidifying agent, any of that, right? Because it's an aldehyde to acid. So we can use any of that, right? And here what will be our E? What is converting to aldehyde in presence of, its reduction in presence of palladium and BaSO4, catalytic.
Acid chloride, ma'am.
So this is our acid chloride. So it is ethanol. So it will be a chloro, is it not?
Yes, ma'am.
Ethanol chloride. And from ethanol chloride to amide. So our G will be
Ammonia, madam.
ammonia, right? Ammonia will convert acid chloride also to amide. And here they have also shown acetic acid with ammonia to amide. Only thing here, heating will also be necessary. And amide, bromine KOH is what reaction?
Hoffman bromide.
Hoffman bromide. So here we are getting
CH3.
C will be methenamine, right? And with nitrous acid, D.
Ethanol.
Yes, aliphatic amine. So it is
Aniline.
methanol, right?
Methanol.
Methanol. And aliphatic amine, so it will directly convert to ethanol and methanol and nitrous acid.
Okay,
And
okay.
D with PCl5, naturally we are getting this. So
Okay.
I think we have just discussed this. So when we go in for teaching children a lot, after teaching the basic reactions, we can go for questions like this, where we have matching the following. So this is just an example with the nomenclature, matching the following type of questions, then filling up of A, B, C. So all sorts of questions we can try out. So once organic is taught, I feel the basic, it comes in from practice only. Children will find initially difficult, but once they learn and they get into this, they'll find an interest in learning in this way. So we have to teach or train the children in this type of pattern, type of questions. Now the child will readily begin to learn all this.